Quick, graph y equals the cosine of x minus 3 by hand, 2 different ways. This is part of the family of functions series. You will need paper and straight edge. We suggest you create grids similar to the ones at the right as needed, and press pause as needed anytime during the video. The first way is with the cosine dance. Recall the graph of one period or wave of the cosine function. Notice the 5 key points of interest. These key points are affected by the parameters in the equation, and in this equation we only have one parameter, and it affects the y-coordinates. The minus 3 shifts all points down 3 units. So the initial point normally on the cosine function is going to be shifted down 3 to 0, negative 2. So let's go ahead and plot that. That's going to be our maximum. The end of the first period, normally at 2 pi comma 1, will be shifted down 3 to 2 pi comma negative 2. Halfway between the start and end of the period is a minimum point, normally at pi negative 1, but we just shift that down to pi negative 4 and plot that. Halfway between a max and a min is a point of inflection. So normally that's at pi over 2, 0. Here it's going to be pi over 2 down 3 to negative 3. Pi over 2, negative 3. Plot that. And similarly, halfway between the min and the max is another point of inflection. Normally at 3 pi over 2, 0, but for our purposes, down 3 to 3 pi over 2, negative 3. Pause is needed. Connect the points as a cosine wave, frown or concave down, smile or concave up, frown or concave down. And this is just one period of the cosine wave. Let's duplicate the wave in the negative direction. So we'll go from each key point back the period, 2 pi, maximum, then a point of inflection, then a minimum, second point of inflection, and now we're ready to connect the points as a cosine wave like we did before. Drawing the line that contains the points of inflection helps out here. So what is the equation? Pause is needed to figure out the equation of that line. And it's y equals negative 3. And some of you may say, where does that minus 3 come from? And it comes from that in the equation. Let's compare this to the parent function in blue. And you can see going from blue to green, each point is shifted down 3 units. So we say that the parent function is shifted down 3 units or translated down 3 units. Pause is needed. A second way to do this would be using a table. So we'll start with our axes values in the table and ask you to create a second table here in green. We're going to subtract 3 from each of the y-coordinates only. There's nothing happening to the x-coordinates. So we're going to keep those x-coordinates the same. So let's just go ahead and populate the table there with those values. And let's go ahead and subtract 3 from each y-coordinate. So 1 minus 3 is negative 2. Let's plot 0, negative 2. 0 minus 3 is negative 3. So pi over 2, negative 3. Negative 1 minus 3, negative 4, pi, negative 4. 0 minus 3 is negative 3, 3 pi over 2, negative 3. And 1 minus 3, negative 2, 2 pi, negative 2. Let's connect the points as a cosine wave. Frown, smile, frown. And we can plot another period to the left, as we did before, coming back 2 pi from each of the key points. And we'll connect those into a cosine wave. Comparing that to the parent function, y equals cosine x in blue. From blue to green, we go down 3 every single point. And so we say the parent function is shifted down 3 units or translated down 3 units. Now you try one. Graph y equals a cosine of x minus 1. Use either method or both for the practice. Pause as needed. Resume when you're finished to see the answer. And so the green is our answer. We also show the parent function to show that each point is shifted down or translated down 1 unit.